the Snapchat, put it in prison.
I'm trying to cut it off.
Okay, put it in prison.
I don't know how to cut.
5 from the assignment before we put it in the piles. So number 5 said 216 over 216 to the negative 3n equals 36 to the negative 2n minus 2. And if you were to do this problem, you would use the charts. And which column on the chart would you be looking at? The 6s. So 216 is 6 to the 3rd. 216 to the negative 3n would be 6 to the 3rd to the negative 3n. 36 would be 6 to the 2nd to the negative 2n minus 2. No, just because it's a 216, not a 1 over 216. Yeah. All right, so this is what we have. We have a couple spots where we have an exponent that is raised to an exponent. Karma, the Chromebook needs to be away. So 3 times negative 3n would be negative 9n. And then over here, we can distribute the 2. And then before we go further, Brooks, do I have a cell phone I need? Oh, it's a pencil. You're good. You're good. So over here, we have to remember our exponent rules. So does anyone remember off the top of their head what this rule is? Yeah. If it's division, you have to subtract. Yeah. So just like we asked the other day, if you guys remember, and it could be good to write this somewhere, maybe on your cheat sheet or something. The other day I said like x to the 5th times x to the 2nd. And you guys were all like, yeah, x to the 7th. We remember that. The one that we don't remember as easily is if we had like x to the 9th over like x to the 6th. That would be x to the 3rd. And it's because this rule is you just subtract them. All right? So for a problem like this, you would subtract your exponents. You would get x to the 3 minus negative 9n. So 3 minus negative 9n. And then 6 to the negative 4n minus 4. Now, you don't have to do this as a division problem. If you were uncomfortable in the very beginning with the division part of it, you could actually change the problem from the beginning and just avoid division altogether. In the very beginning, you could have said times 216 to the negative 3n times 216 to the negative 3n. And you could have changed it to a multiplication problem, which would have meant you were adding your exponents instead. So you could have done that, and then it would have been more familiar because we did multiple problems with multiplying and adding exponents. So that's also an option if you wanted to avoid the division. Okay? All right. So at this point, we can just get rid of the bases. We've got 3 plus 9n equals negative 4n minus 4. And then what should we do from there? Add the 4n. So, subtract the 3? Okay. Yeah, you could have added both 4s, but then everything would have ended up on the left side. So we have 13n equals negative 7. And so n equals negative 7/13. Okay, and do we remember how to check our answers and make sure that they're right? Okay, so I could do save negative 7/13, so I could store as x. And then go back to the original problem and just type this in and make sure the two sides of the equal sign are the same. So 216 over 216 to the negative 3x, and I get this funky decimal. And then on the right side, I have 36 to the negative 2x minus 2, and I get the exact same funky decimal. So I know I got it right. Okay. All right. So go ahead and take the 2-block assignment, make a pile on your table. They should be somewhat familiar. This content, part of it is not Math 3 level, and then part of it we're introducing the concept again, because part of it we add in and then we say, oh, now it's Math 3 level because now we can do a little bit more with it. So you might recognize exponential growth and decay. You might recognize these formulas because I think that you have worked with them before in lower level math classes. At this point, the coloring should be away. We shouldn't be working on this anymore. All right. Angelina, are we coloring? Done? Okay. All right, so the first formula we have is exponential growth, and as we go through all the formulas, I'm going to define what all the variables stand for. So sometimes you can see an A here, sometimes you'll see a Y, but this stands for the final amount, like the answer, the final amount, or the answer. The t value over here, that is the exponent, this is the time. And it is usually in years. Usually in years. So we have the final amount, and we have the time, which is usually in years. In exponential growth problems, the type of wording that we're going to expect to see is something about an increase. So you're going to see maybe the word increasing, or you might see that something is appreciating in value, which means that something is going up in value. So appreciating in value is moving in the positive direction. And you'll be able to see that in problems where the 1 plus r has been simplified, because 1 plus r will always be a number that's bigger than 1. So r will describe down here, but it's a rate, like a percentage. And so this number would always be bigger than 1. The base of your exponent will always be bigger than 1 if that number is increasing, getting bigger. All right, here the p-value is the principal amount, and you don't have to write principal if that's not a number that's in your vocabulary. It just means starting. So you can write principal amount, or you could write starting amount. That's what the p stands for, principal amount or starting amount. The r is the rate as a decimal. The rate as a decimal. So if we had 5% as a decimal, that would be 0.05. If we had 1.9% as a decimal, that would be 0.019. If we had 23% as a decimal, that would be 0.23. So if you have a percentage that already has a decimal in it, you take the decimal and you move it 2 places to the left. If you have a whole number, the decimal place in a whole number is at the end of the whole number. So 5 would be like 5.0, and you take the decimal and you move it 2 points to the left. So 5.0, move it 2 points to the left would be 0.05. 23 would be 23.0, move it 2 points to the left. Okay, so you always take your percentage, move the decimal 2 points to the left, and that's the percentage written as a decimal. The words that we would expect to see in a decay problem would be decreasing or depreciate. And we're going to notice that since the base of this exponent is 1 minus the rate, that the base to these exponents are always going to be something less than 1. So you might see like 0.89 to some exponent, or like 0.77 to an exponent, or 0.62 to an exponent. But you're going to notice the base is less than 1, and that's what's making that number go down over time. Right? Okay, next is compound interest. And so they say that the interest is compounded a certain number of times per year. So it's not just annually, which is what this is, that you're getting the interest added to the account or whatever one time per year, but it could be more often. So semi-annually would be every 6 months. That would be twice per year. Quarterly would be how often? Yeah, 4 times per year, so every 3 months. Monthly, yeah, monthly is the next one. Monthly would be how often? Every month. And how many times per year is that? 12, okay. Weekly would be how many times per year? 52. And then daily would be how often per year? 365, unless it's a leap year. 366, because then you have February 29th. It's one day. Yep. So, and then the N over here is what these are. These are the N values. And N is the number of times per year. So it's the number of times the interest is compounded per year. And so the way that you're going to know that you're using this formula is it's going to have one of these words in it, and it usually has the word compound in it. Okay? All right, so this is what each of the variables stand for, and then these are the words we're going to look for to help us determine which formula. Okay. Are we good so far? Okay. So, example 1. It says movie tickets now average $9.75 per ticket, but they are increasing by 15% each year. So it said the word increasing, which means we're using the growth formula. So we've got A equals P times 1 plus R to the T. So based on the problem, what is the principal or the starting value? 975. Okay. What is the rate? Yeah, 15%, which is going to be 0.15. And then what's the time we're going to use? 5. Okay. So the way this first question is phrased, this is not a Math 3 question. This is a Math 1, maybe an 8th grade question. I'm not sure when you first learn exponential. But this is not a Math 3 question because this is like a plug and chug. Just put the numbers where they should be in the formula. Type it in your calculator. Get the number. And put it in a sentence. And then you're done. Yeah, because it's a story problem. All right, and this is a dollar amount, so even though we normally do 3 decimal places, for this one we're just going to do 2 because we're doing cents. So $19.61. Movie tickets will cost $19.61 5 years from now. When I was growing up, we thought that $10 for a movie ticket was like astronomical. Like it is astronomical. I remember like paying a couple bucks, like $2 to go see the movies. It's wild. If you're a student, where are you guys going to see movies that you can pay $6? Where? That's so okay. So we're not going to Raleigh because they're definitely $10 there.
You know, it's really good. That movie theater.
You guys know not everybody lives in Roxborough, right? I live in Durham. I'm just saying. I'm not. I know. I'm just saying. I'm just saying. Normal movie theaters, non-Roxborough places.
The one that serves you dinner.
Which one?
It's one in, I think,
Mm-hmm.
Charlotte.
I've heard of them. I don't really go to movies very often, so. All right. Now the next question in here. This question is a Math 3 question because they changed the wording, so they change what you're solving for. And the way they change it makes it a Math 3 question, okay? So they change the question and they say when. It's a when question, which means your variable is what? It's t, it's the time. We're going to solve for the exponent, and so it just became a Math 3 question. Because until this unit in Math 3, you wouldn't have known how to solve this. Okay? So they changed it. We no longer know that it's 5 years. Now we don't know the time. And now we do know that the final amount is $17. Okay? So we're going to change the t to be a question mark. We're going to change the final amount to $17. So 17 equals 975, but everything else stays the same. So same starting amount, same rate, but now we don't know the time. So it became a Math 3 question because this is where we are solving an exponential equation. We're going to get t by itself. Yeah. We are going to divide it. So I'm going to go ahead and do my normal steps backwards like I always do. So is there a way I can add or subtract something to the other side? Nope, can't do that. Second step, is there something I could multiply or divide to the other side? Yep, the 9.75. Now, if I do 17 divided by 9.75, do I get a nice decimal? No? Okay. So I'm going to leave this as a fraction then because I don't want to round just yet.
So why did you divide that?
I am undoing steps that are by the t. And so this is multiplied, so I did division to undo it. Okay. So 1 plus 0.15, are we okay with calling that 1.15? Okay, so I'm just going to simplify this a little bit. 1.15 to the t power. Okay. So my next step is exponents. I want to get to my exponent. I need to get rid of the base. Log. A log. And what's the base of the log? 1.15. So this is what we learned yesterday. We did this yesterday. So if you want to get rid of a base, you have to log it using that same base. So log 1.15. We're doing that on both sides. And when we do that on the right side, it gets the t to be all alone. And when we do it on the left side, it tells us what we're going to be plugging into our calculator. Do we have to what? Yeah, and so we're going to plug it in our calculator. And your calculator is going to pop up these parentheses, and this is what we're going to put in the parentheses. So how do we type in log of 1.15? Math up, math up, 1.15, and then 17 divided by 9.75. Okay. So t is approximately 3.978. 3.978 years, yeah. So we're going to say the movie tickets will cost Okay. The ones with dinner and recliners and
Look,
I-
you can do
I
that at your
wouldn't
house.
pay for
You
that
get
one.
you like a nice steak and then you can watch.
all right. A powerful computer is purchased for $2,000 but loses 20% of its value each year. So what formula should we use? Decay. It's decreasing. Decay. So we got A equals P 1 minus R to the T. So what is the starting value? 2,000. Okay, what's the rate? 20%. We're going to write that as 0.20. And the time is 4. So this is the question that is not Math 3 level. This is just plug and chug.
Will you just write 0.2 instead of 0.1?
You can write 0.2, yeah. You can write 0.80.
Computers and phone stuff decreases by 30%.
Can you scoot it over a little bit?
Which way?
Is that a one in front of that? Or behind it?
It's a dollar sign. All right, the next question says, when will the computer be worth $100? So we're changing it so we don't know what T is, and so the final amount is going to be 100. So we're going to say $100. We're still keeping the initial value. We're still keeping that it decreases by 20% each year. We just don't know how many years it is. Okay. So, is there anything I can add or subtract to the other side? Nope. Is there anything I can multiply or divide to the other side? The 2,000. .05, okay? 1 minus 0.20, let's do what CJ had said earlier, and let's use 0.80, because it makes life easier. So 1 minus 0.20 is 0.80. So this... Okay, so now we want to get to the exponent. The base is in the way. So we're going to do log base 80, log base 80, So t equals log base 80, well, 0.80 of 0.05. So how long does it take for that computer to be worth $100?
13 years. 13 and a half. About 13 and a half.
It's not 13 and a half, it's 13.45.
14 left. 14.
Peyton, did you write your sentence?
Yeah.
Yes.
We doing all these examples?
We're going to do one more.
We gotta do the compound.
Go ahead and flip the paper over.
We gotta do compound.
Mm-hmm.
I've done nothing to deserve that.
I didn't do that.
Not until we're done with the notes. That's what your sleeve is for, man. Just wipe it. It's like a built-in piece of Kleenex. If you don't want it to show, just use like the inside. All right. Jasmine invests $2,685 into a retirement account with a fixed annual interest rate of 1.9% compounded quarterly. Yes. I mean, you get a cheat sheet anyway. Don't forget. I mean, today's the day before the review. Tomorrow is the review when you make your cheat sheet.
Then I got 2 days of doing nothing.
Yeah. You don't realize, after Friday at 3 o'clock, I don't remember anything you said. Monday, I need to go on that week. And then that's it. It's not a lot to go.
It's a little better than
Snacks.
Alright, can we start talking so we can
Yeah, we got to go faster so Kurt can wipe his nose. All right. Now it says compounded quarterly. So what formula are we using? The last one. So A equals P times 1 plus R over N to the NT. Notice the N gets used twice. Okay, our starting value is 2685. The rate is 1.9%, which is, what is a decimal? 0.019. The compounded quarterly is what for N? 4. And the time is what? Okay. So A equals 2685 times 1 plus 0.019 over 4 to the 4 times 15. Mm-hmm. Yeah, you could. Quarterly. $3,568 and 0 cents.
Hey, I got a quick question. It might be off topic, but it kind of. What's the candle's name in the Beauty and the Beast?
Right.
Pierre.
A candle.
It's Pierre, right?
No, it's candle.
I swear it's Pierre.
We're talking about candles.
Not racist.
That's Yankee Candle.
Yankee Candle, bro.
What's Candle's name? In Beauty and the Beast.
He is too. Are we done? Are we done?
Now we know. You're welcome. All right.
Clock.
I got cozy to bed. I'm not doing that.
Nah. I don't know, but I noticed in my bank account my interest rate went from like a low one-digit number, like 2 or 3 or something, to like literally 0.25. Yeah. It's gotten real low. My bank account.
Why would her credit score be 2.5?
Oh no, my credit card is like 25%. They're making money.
Why would you solve this?
Yeah.
We getting like 25.
A lot. A lot. Yeah. So I think I did the questions in pairs. One where you just plug and chug, and then one where you find T. No, I think I did them in pairs there too. Yeah. I could be wrong though. I might have done. Georgia, I'll have to look and see what I did on the test. Yeah. All right. Now this question is an interesting one because of the way they phrased it. Yeah, so it says when will the account double? And when they phrase it this way, they're not talking about your ending amount. They're talking about the principal. So when will the account double? You want to take your principal amount and you want to double that. It's a pretty common thing for them to do, is to say, when will the account double? When will it triple? When will it quadruple? And a lot of students don't know how to handle it because they didn't give you an amount. They did give you an amount, you just have to do some math to find it. So we're going to take our principal. Yeah, 5,370. That's the final amount we want to get to. And then everything else is going to stay the same, but we're going to be solving for T. First thing we're going to do is divide. And when we divide it, we're going to get 2. All right, we'll come back and finish this problem after lunch. Okay, so we had just started solving this one. We plugged all the numbers in. We knew that we had to divide the 2,685. Hey guys, let's put down the sharpener and the coins. Because we're put it down, put it down, put it down, put it down. Okay. So we're dividing. We found out when we divided it was just 2, which makes sense because the amount doubled. So there's the doubled. Okay. And then let's see if this number right here is nice or not. So let's go ahead and plug that in, because if we can avoid writing 1 plus 0.09 divided by 4, that would be helpful.
1.005.
1. No, we can't round.
Oh, so 1.00475.
Okay. 1.00475. Okay. So the important thing in these problems, are you listening? Okay. The important thing in these problems is we cannot round in the middle of a problem. So if you're going to have to round, then you got to leave something as a fraction. No rounding. Okay? Thank you. He didn't catch it, but I did. Appreciate it. All right. So we did there's no addition subtraction. We did the multiplication division step. Now we're trying to get to the exponent, but there's a base in the way. So we got a log and this terrible base, 1.00475.
That's a whole lot.
But it's nicer than this base would have been. 1 plus 0.019 over 4 as a base.
Wouldn't it be 1 and then 0.949 over?
This whole thing is the base.
Yeah.
All right, so we've got 4t equals log base 1.00475 of 2. And then we got to divide by 4. It's not too much. We can do it. It's not too bad. Okay, so how do I type that in my calculator? You can do it as a fraction. Okay. Math up. 1.00475 2 4. You guys typing it? We typing it? You literally said yes.
My calculator right
You got the answer? Let me see.
My calculator.
Uh-huh. 36.568. So the account will double in value. All right. You guys write your sentences. Okay. It's a long time.
get no money.
Yeah. So after this, there's another compound problem, and then there's another growth problem. Do you guys want more examples, or do you feel ready to do the practice assignment? Practice? Practice? Okay.